Hi everyone in 3U Chemistry and 4C Chemistry. So today we're going to continue looking at solutions. So far you've learned a lot of terminology and you've been learning how to figure out the concentration of a solution. And we've been just focusing on molar concentration or molarity, which means the number of moles of solute in a liter of solution. So when we begin with a solution that we know the concentration of, we can make new solutions, and that process is done through dilution. We can go from concentrated to more dilute, but it's pretty much impossible to go the other way from dilute to concentrated because it is much more difficult to be accurate if you're, evaporating away the liquid portion or solvent from your solution. Whereas diluting, you can be very precise. So a dilute solution, as shown in this picture here, has much fewer moles of solute compared to a concentrated solution for the same volume. And when you add water to a solution, that is called dilution. Okay, so a little example I just want to look at here is these two beakers. Scroll this down a little bit. Okay, so this is going to be beaker number 1 and beaker number 2. So at first, just for easy sake, I noticed that there are 13 little dots in the beaker. So I've said there's 13 moles per liter is going to be this concentration. That's pretty strong, but anyways. And this is just a 1 liter beaker, we're going to say. Okay, so it's 1 liter. And then we put it into a larger beaker and then just pour water in until we now have 4 liters. Okay, but if you count those up, you'll see that there are still 13 particles. So did the volume change? Yes, it definitely does. When you do a dilution, you are going to increase your volume. Does the concentration change? Yes, it does. And if you look at it, this looks way more crowded than this, so concentration actually decreases when you do a dilution. Now, very importantly, did the number of moles of solute change? So count them, 13, still 13, so no. Which means that the initial moles is identical to the final moles. Okay, so initial moles is equal to your final moles. Now, for initial, we sometimes use a little I or just a number 1. Moles is N, as we know. And for final, we could use an F or a number 2. Different textbooks use I's, F's, 1's, 2's. It doesn't matter. Now, we're saying moles is equal to moles when you're done. Now, if we think back to what you've been working on in our last lesson, which is figuring out the concentration of something, and if I put our formula into a magic triangle, so concentration is moles divided by volume, then moles, N, is actually equal to concentration times volume. So we can sub that in to this because we know initially and finally moles are the same. So let's just plug instead, let's say C1V1 is equal to C2V2. So the initial set of conditions for concentration and volume are going to be equal to the final set of conditions. So that is our dilution formula, which I have right here in a box for you. And as I've shown you, it is really just derived from our concentration formula because of what happens during a dilution, and the important thing being that the number of moles doesn't change, just the solvent, and therefore the volume of the solution. So let's figure out what our new concentration in this beaker is, because this is our mystery up here. Now, I think it's a very good idea to be organized, as always, and write down everything you know and everything you need. So final concentration, C2 or CF, that is our question. Initial concentration, I told you it was 13 moles per liter when we started with the small beaker. The initial volume, just to make life easy, was 1 liter in that beaker. And then the final volume, we poured it into a different container, but then we topped it up with water, and we ended up making 4 liters. Okay, so to rearrange this formula, whatever you're solving for, which in our case here is we want C2, the other side is not going to be changed. But what you have to realize is currently C2 is being multiplied by V2. So to get rid of V2, you would need to divide it out. So essentially, and I can write this the other way too, which I'm going to do just so that we end up with C2 on the left side, which is where I like to see it. Okay, so if we divide both sides by V2, so if you divide that by V2 and you divide that by V2, that's how you get rid of it. So C2 is equal to C1 V1 over V2. Okay, and now we're going to plug in. So initial was 13 moles per liter. Initial volume was 1 liter. Final volume was 4 liters. Comes out to 3.25. Oh, and by the way, these liters will cancel and you will be in moles per liter. Now, because I was kind of being lazy here, I just said 1 liter and 4 liter. We can actually only have one significant digit. Okay, now this is where you ask yourself, does my answer make sense? Because if not, you've possibly done an algebraic problem with rearranging your formula. And if you look, the initial concentration was 13 moles per liter, so 3 moles makes sense because we know that our concentration should be getting less if we're pouring water into it. Okay, so in terms of the two concentrations, the concentration, whoops, got that in the wrong spot. The second concentration should always be the smaller number, okay, and therefore this guy's the larger number, the initial concentration. But with volumes, it's completely opposite. The second volume will always be much bigger because you've poured water into it, and this one's going to be smaller. So you can just, if you just kind of keep that in the back of your mind, you can make sure that your answers seem reasonable. Okay, so we'll do one more example here. So what volume of 18 mole per liter sulfuric acid is required to make 250 mils of a 0.25 mole per liter sulfuric acid solution? Now this is a type of problem I'm faced with all the time in the chemistry lab because we buy sulfuric acid very concentrated, 18 moles per liter as a matter of fact, and then we never use it like that because it's quite dangerous. So I make solutions up that we use for experiments. So I have to know, what do I need to actually make this required concentration that I want? Okay, so what volume of it is needed is kind of the question. Because I see the word to make 250 mils, that's how I know that that's what I'm going to end up with for volume. This question is asking for V1, okay? And the concentration of that very, very strong stuff that we're going to be using is 18 moles per liter. So V2, because of the keyword to make, 250 mils. Now don't forget, just like when we're doing our other calculations, you can't be in mils. So you're going to need to use the conversion factor, and you're going to have 0.250 liters there. And the final much safer concentration that we're looking for is 0.25 moles per liter. Okay, so get your stuff organized. Then we'll go to our formula. And this time we want V1. So again, to get rid of C1, we're going to divide it out of both sides. So notice how this doesn't change, but it is being now divided by C1. Okay, so plug it all in the right spots. B2 is 0.25 liters, initial concentration, 18 moles per liter. Notice those units are going to completely cancel and we'll end up with liters, which makes sense being as we're doing a volume. And for this, we are going to get 0.00347 liters. We're only allowed 2 significant digits. So a perfectly, acceptable answer would be that. That is fine. It's not great. Maybe we'd like to put it in scientific notation instead. So like 3.5 times 10 to the negative 3 liters, because we've moved the decimal 3 places. Or we could even change it into milliliters. It could also just be 3.5 milliliters. So any of those are good. And the first answer is, as I said, perfectly fine. It's just probably not how you would see it written. Okay. Now, because I'm doing this in the lab, I need to know how much water am I actually going to add to make this happen. So I am ending up with 250 mils of solution. That's what I'm going to end up with. And we just figured out that I'm only putting in 3.5 mils of this very strong acid. So if I want to know how much water I have actually added, it's the difference. So 246.5 mils of water added. So just be careful of wording of questions because sometimes it might ask you for that. Okay, so this is our final solution. Is our acid, and this is the water that we've added. Okay, that will be all for today. Good luck with your questions.